Welcome to the Manual for Blender, the free and open source 3D creation suite. With Blender, you can create 3D visualizations such as still images, 3D animations, and VFX shots. You can also edit videos. It is well suited to individuals and small studios who benefit from its unified pipeline and responsive development process. Being a cross-platform application, Blender runs on Linux, Mac OS, as well as Windows systems. It also has relatively small memory and drive requirements compared to other 3D creation suites. Its interface uses OpenGL to provide a consistent experience across all supported hardware and platforms. Who uses Blender? Blender has a wide variety of tools, making it suitable for almost any sort of media production. Professionals, hobbyists, and studios around the world use it for creating animations, game assets, motion graphics, TV shows, concept art, storyboarding, commercials, and feature films. Check out the user stories page on the Blender website for more examples. Key features. Blender is a fully integrated 3D content creation suite, offering a broad range of essential tools, including modeling, rendering, animation and rigging, video editing, VFX, compositing, texturing, and many types of simulations. It is cross-platform, with an OpenGL GUI that is uniform on all major platforms, and customizable with Python scripts. It has a high-quality 3D architecture, enabling fast and efficient creation workflow. It boasts active community support. See blender.org/community for an extensive list of sites. It has a small executable, which is optionally portable. Blender makes it possible to perform a wide range of tasks, and it may seem daunting when first trying to grasp the basics. However, with a bit of motivation and the right learning material, it is possible to familiarize yourself with Blender after a few hours of practice. This manual is a good start, though it serves more as a reference. There are also many online video tutorials from specialized websites. Despite everything Blender can do, it remains a tool. Great artists do not create masterpieces by pressing buttons or manipulating brushes, but by learning and practicing subjects such as human anatomy, composition, lighting, animation principles, etc. 3D creation software such as Blender have an added technical complexity and jargon associated with the underlying technologies. Terms like UV maps, materials, shaders, meshes, and subdivs are the media of the digital artist, and understanding them, even broadly, will help you to use Blender to its best. So keep reading this manual, learn the great tool that Blender is, and keep your mind open to other artistic and technological areas, and you, too, can become a great artist. Blender history. In 1988, Ton Roosendal co-founded the Dutch animation studio Neo Geo. Neo Geo quickly became the largest 3D animation studio in the Netherlands and one of the leading animation houses in Europe. Neo Geo created award-winning productions, European Corporate Video Awards in 1993 and 1995, for large corporate clients such as the multinational electronics company Philips. Within Neo Geo, Ton was responsible for both art direction and internal software development. After careful deliberation, Ton decided that the current in-house 3D tool set for Neo Geo was too old and cumbersome to maintain and needed to be rewritten from scratch. In 1995, this rewrite began and was destined to become the 3D software creation we all know as Blender. As Neo Geo continued to refine and improve Blender, it became apparent to Ton that Blender could be used as a tool for other artists outside of Neo Geo. In 1998, Ton decided to found a new company called Not a Number, NAN, as a spin-off of Neo Geo to further market and develop Blender. At the core of NAN was a desire to create and distribute a compact, cross-platform 3D application for free. At the time, this was a revolutionary concept as most commercial 3D applications cost thousands of dollars. NAN hoped to bring professional-level 3D modeling and animation tools within the reach of the general computing public. NAN's business model involved providing commercial products and services around Blender. In 1999, NAN attended its first SIGGRAPH conference in an effort to more widely promote Blender. Blender's first SIGGRAPH convention was a huge success and gathered a tremendous amount of interest from both the press and attendees. Blender was a hit and its huge potential confirmed. Following the success of the SIGGRAPH conference in early 2000, NAN secured financing of €4.5 million from venture capitalists. This large inflow of cash enabled NAN to rapidly expand its operations. Soon NAN boasted as many as 50 employees working around the world trying to improve and promote Blender. In the summer of 2000, Blender 2.0 was released. This version of Blender added the integration of a game engine to the 3D application. By the end of 2000, the number of users registered on the NAN website exceeded 250,000. Unfortunately, NAN's ambitions and opportunities did not match the company's capabilities and the market realities of the time. This overextension resulted in restarting NAN with new investor funding and a smaller company in April 2001. 6 months later, NAN's first commercial software product, Blender Publisher, was launched. This product was targeted at the emerging market of interactive web-based 3D media. Due to disappointing sales and the ongoing difficult economic climate, the new investors decided to shut down all NAN operations. The shutdown also included discontinuing the development of Blender. Although there were clearly shortcomings in the then-current version of Blender, such as a complex internal software architecture, unfinished features, and a non-standard way of providing the GUI, the enthusiastic support from the user community and customers who had purchased Blender Publisher in the past meant that TUN could not justify leaving Blender to fade into insignificance. Since restarting a company with a sufficiently large team of developers was not feasible, TUN Rusendel founded the nonprofit organization, Blender Foundation, in March 2002. The Blender Foundation's primary goal was to find a way to continue developing and promoting Blender as a community-based open-source project. In July 2002, TUN managed to get the NAN investors to agree to a unique Blender Foundation plan to attempt to release Blender as open source. The Free Blender campaign sought to raise €100,000 so that the foundation could buy the rights to the Blender source code and intellectual property rights from the NAN investors and subsequently release Blender to the open source community. With an enthusiastic group of volunteers, among them several ex-NAN employees, a fundraising campaign was launched to Free Blender. To everyone's surprise and delight, the campaign reached the €100,000 goal in only 7 short weeks. On Sunday, October 13, 2002, Blender was released to the world under the terms of the GNU GPL. Blender development continues to this day, driven by a team of dedicated volunteers from around the world led by Blender's original creator, TUN Rusendel. Installing Blender. Blender is released approximately every 3 months. You can keep up to date with the latest changes through the release notes. System requirements. Blender is available for download on Windows, Mac OS, and Linux. Always check that the graphics drivers are up to date and that OpenGL is well supported. Blender has a set of minimum and recommended requirements, so make sure these are met before trying to install Blender. Support for other hardware such as graphic tablets and 3D mice are covered later in configuring hardware. Download Blender. Blender offers a variety of different binary packages to choose from depending on their level of stability. Each package has the trade-off of newest feature versus stability. The package that is right for you depends on your requirements for those two. A studio, for example, might want to have long-term support, while a hobbyist may want newer features, while others may just want to test upcoming features. Each package described below has something just right for everyone. Stable release. A package that contains the latest features and is considered stable without regressions. A new stable version is available about every 3 months. Long-term support. A package designed for long-lasting projects requiring a very stable version of Blender. LTS releases are supported for 2 years and will not have any new features, API changes, or improvements. A new long-term support version is available every year. Daily builds. A package updated daily to include the newest changes in development. These versions are not as thoroughly tested as the stable release and might break, although they are official and usually not highly experimental. Note: Blender's source code is available for free to either reference or to build from source. While normal users are not expected to compile Blender, it does have advantages. Blender is always up to date. It allows access to any version or branch where a feature is being developed. It can be freely customized. The procedure for installing a binary, either the latest stable release or a daily build, is the same. Follow the steps for your platform. Note: Blender doesn't have a built-in updating system. This means you will need to update Blender yourself by following the upgrade steps described in the sections below. User Interface Window System Introduction. After starting Blender and closing the splash screen, the Blender window should look similar to the image below. The default startup Blender window. Blender's interface is separated into 3 main parts. The top bar at the very top consists of the main menu, which is used for saving, importing and exporting files, configuring settings, and rendering, among other functions. Areas in the middle, which is the main workspace. The status bar at the bottom, which displays shortcut suggestions and relevant statistics. Blender's default screen layout. Top bar, blue, areas, green, and status bar, red. Customization. Keyboard shortcuts. Blender makes heavy use of keyboard shortcuts to speed up work. These can be customized in the key map editor. Theme colors. Blender allows for most of its interface colors to be changed to suit the needs of the user. If you find that the colors you see on screen do not match those in the manual, it could be that your default theme has been altered. Creating a new theme or selecting/altering a pre-existing one can be done by opening the Preferences and clicking on the Themes tab. Accessibility. Blender has several options for visibility customization, including resolution scale and the ability to load custom fonts. These settings can be configured in the interface preferences. User Interface Splash Screen. When starting Blender, the splash screen appears in the center of the window. It contains options to create new projects or open recent ones. A more detailed description can be found below. Blender Splash Screen. To close the splash screen and start a new project, click anywhere outside the splash screen, but inside the Blender window, or press Escape. The splash screen will disappear, revealing the default screen. To reopen the splash screen, click on the Blender icon in the top bar and select Splash Screen. Note: when starting Blender for the first time or updating to a new version, the interactive region contains a quick setup process. Splash Image. The upper part of the splash screen contains the splash image with the Blender version in the top right. Interactive region. The interactive region is the bottom half of the splash screen. New file. Start a new project based on a template. Recent files. Your most recently opened Blend files. This gives quick and easy access to your recent projects. Open. Allows opening an existing Blend file. Recover last session. Blender will try to recover the last session based on temporary files. See Recovering Data. Donate. Open Blender's Development Fund website. What's new? Open the latest release notes. User Interface Top bar. Menus. Blender menu. Splash Screen. Open the splash screen. About Blender. Opens a menu displaying the following information about Blender. Version, the Blender version. Date when Blender was compiled. Hash, the Git hash of the build. This can be useful to give to support personnel when diagnosing a problem. Branch, optional branch name. Windowing environment. On Linux, this will show either Wayland or X11 depending on the windowing environment that Blender is running on. Donate. Open Blender's Development Fund website. What's new? Open the latest release notes. Credits. Open the credits https://www.blender.org/about/credits/___ webpage. License. Open the license webpage. Blender Store. Open the Blender Store website. Blender website. Open main Blender website. Install application template. Install a new application template. File menu. The options to manage files are: New Control N. Clears the current scene and loads the selected application template. Open Control O. Open a blend file. Open Recent Shift Control O. Displays a list of the most recently opened blend files. Select any of the file names in the list to open that blend file. With that, reopens the current file to its last saved version. Recover. Recover last session. This will load a blend file that Blender automatically saves just before exiting. So this option enables you to recover your last work session, e.g. if you closed Blender by accident. Recover Autosave. This will open an automatically saved file to recover it. Save Control-S. Save the current blend file. Save incremental Control-Alt-S. Save the current Blender file with a numerically increment name that does not overwrite any existing files. Save as. Shift Control-S. Opens the file browser to specify file name and location of save. Save Copy. Saves a copy of the current file. Link. Links data from an external blend file, library, to the current one. The editing of that data is only possible in the external library. Link and append are used to load in only selected parts from another file. See linked libraries. Append. Appends data from an external blend file to the current one. The new data is copied from the external file and completely unlinked from it. Data previews. Tools for managing data block previews. Import. Blender can use information stored in a variety of other format files which are created by other graphics programs. See Import, Export. Export. Normally you save your work in a blend file, but you can export some or all of your work to a format that can be processed by other graphics programs. See Import, Export. External data. External data, like texture images and other resources, can be stored inside the blend file, packed, or as separate files, unpacked. Blender keeps track of all unpacked resources via a relative or absolute path. See Pack or Unpack External Data. Automatically pack into .blend. This option activates the file packing. It's enabled every time the blend file is saved. All external files will be saved, packed, in it. Pack all into .blend. Pack all used external files into the blend file. Unpack into files. Unpack all files packed into this blend file to external ones. Make all paths relative. Make all paths to external files relative paths to current blend file. Make all paths absolute. Make all paths to external files absolute equals full path from the system's root. Report missing files. This option is useful to check if there are links to unpacked files that no longer exist. After selecting this option, a warning message will appear in the info editor's header. If no warning is shown, there are no missing external files. Find missing files. In case you have broken links in a blend file, this can help you to fix the problem. A file browser will show up. Select the desired directory, or a file within that directory, and a search will be performed in it, recursively in all contained directories. Every missing file found in the search will be recovered. Those recoveries will be done as absolute paths, so if you want to have relative paths, you will need to select Make All Paths Relative. Note: recovered files might need to be reloaded. You can do that one by one, or you can save the blend file and reload it again, so that all external files are reloaded at once. Clean up. Unused data blocks. Remove unused data blocks from both the current blend file and any linked data. Cannot be undone. See the outliner for more information. Recursive unused data blocks. Remove all unused data blocks from both the current blend file and any linked data, including any indirectly used data blocks, i.e. those only used by unused data blocks. Unused linked data blocks. Remove unused data blocks from only linked data. Recursive unused linked data blocks. Remove all unused data blocks from only linked data, including any indirectly used data blocks, i.e. those only used by unused data blocks. Unused local data blocks. Remove all unused data blocks from only the current blend file. Recursive unused local data blocks. Remove all unused data blocks from only the current blend file, including any indirectly used data blocks, i.e. those only used by unused data blocks. Defaults. This menu manages the startup file, which is used to store the default scene, workspace, and interface displayed when creating a new file. Initially, this contains the startup scene included with Blender. This can be replaced by your own customized setup. Save startup file. Saves the current blend file as the startup file. Loads factory settings. Restores the default startup file and preferences. When an application template is in use, the following operators are shown. Load factory Blender settings. Loads the default settings to the original Blender settings without the changes made from the current application template. Loads factory application template name settings. Loads the default settings to the original application template. See also Managing Preferences. Quit Control Q. Closes Blender. The current scene is saved to a file called quit.blend in Blender's temporary directory, which can be found under the File Paths tab of the Preferences. Edit menu. Undo, redo, undo history. See undo and redo. Adjust last operation, repeat last, repeat history. See undo and redo. Menu search. Find a menu based on its name. Operator search. Execute an operator based on its name, developer extras only. Rename active item. Rename the active object or node. See Rename tool for more information. That's rename. Renames multiple data types at once. See Batch Rename tool for more information. Lock object modes. Prevent selecting objects that are in a different mode than the current one. Note: this option can prevent accidental mode changes, such as when you're trying to select a bone in pose mode to animate it, but instead click a piece of background scenery, which would normally select that piece and switch to object mode. You may want to disable lock object modes, for example, when weighting rigged objects or sculpting/painting, where you intentionally want to switch between objects in different modes. Preferences Control comma. Open the Preferences window. Render menu. Render image F12. Render the active scene at the current frame. Render animation control F12. Render the animation of the active scene. See also Rendering animations for details. Render audio. Mix the scene's audio to a sound file. See also Rendering audio for details. View Render F11. Show the render window. Press again to switch back to the main Blender window. View Animation Control F11. Playback rendered animation in a separate player. See also Animation Player for details. Preferences for selecting a different animation player than the default one. Lock interface. Lock interface during rendering in favor of giving more memory to the renderer. Window menu. New window. Create a new window by copying the current window. New main window. Create a new window with its own workspace and scene selection. Toggle window full screen. Toggle the current window full screen. Next workspace. Switch to the next workspace. Previous workspace. Switch to the previous workspace. Show status bar. Choose whether the status bar at the bottom of the window should be displayed. Save screenshot. Capture a picture of the current Blender window. A file browser will open to choose where the screenshot is saved. Save screenshot, editor. Capture a picture of the selected editor. Select the editor by clicking LMB within its area after running the operator. A file browser will open to choose where the screenshot is saved. Help menu. See Help menu. Workspaces. This set of tabs is used to switch between workspaces, which are essentially predefined window layouts. Scenes and layers. These data block menus are used to select the current scene and view layer. User interface workspaces. Workspaces are essentially predefined window layouts. Each workspace consists of a set of areas containing editors and is geared towards a specific task such as modeling, animating, or scripting. You'll typically switch between multiple workspaces while working on a project. Workspaces are located at the top bar dot. Controls. Tabs. Click on the tabs to switch between the workspaces. You can also use the keyboard shortcuts Control Page Up and Control Page Down. Double-click a tab to rename the workspace. Add Plus. Click on the Add button to add a new workspace. Context menu RMB. The context menu contains options to duplicate, delete, and reorder workspaces. Default workspaces. Blender's default startup shows the Layout workspace in the main area. This workspace is a general workspace to preview your scene and contains the following editors. 3D viewport on top left. Outliner on top right. Properties on bottom right. Timeline on bottom left. Blender's Layout workspace with 4 editors. 3D viewport, yellow, outliner, green, properties, blue, and timeline, red. Blender also has several other workspaces added by default. Modeling. For modification of geometry by modeling tools. Sculpting. For modification of meshes by sculpting tools. UV editing. For mapping of image texture coordinates to 3D surfaces. Texture paint. For coloring image textures in the 3D viewport. Shading. For specifying material properties for rendering. Animation. For making properties of objects dependent on time. Rendering. For viewing and analyzing rendering results. Compositing. For combining and post-processing of images and rendering information. Geometry nodes. For procedural modeling using geometry nodes. Scripting. For interacting with Blender's Python API and writing scripts. Additional workspaces. Blender has a couple additional workspaces to choose from when adding a new workspace. 2D animation. 2D animation. General workspace to work with grease pencil. 2D full canvas. Similar to 2D animation, but contains a larger canvas. VFX. Masking. For creating 2D masks for compositing or video editing. Motion tracking. For calculating camera motion and stabilizing video footage. Video editing. Video editing. For sequencing together media into one video. Save and override. The workspaces are saved in the blend file. When you open a file, enabling Load UI in the file browser indicates that Blender should use the file's screen layout rather than the current one. A custom set of workspaces can be saved as a part of the defaults. Workspace settings. Reference. Editor. Properties. Menu. Active Tool and Workspace Settings. Workspace. Mode. Switch to this mode when activating the workspace. Filter add-ons. Determines which add-ons are enabled in the active workspace. When unchecked, the global add-ons will be used. When checked, you can enable individual add-ons in the list below. User Interface Status Bar. Status Bar. The status bar is located at the bottom of the Blender window and displays contextual information such as keyboard shortcuts, messages, and statistical information. The status bar can be hidden by disabling Show Status Bar in Window menu or by dragging from the top edge down. Status bar. Key map information. The left side of the status bar displays mouse button shortcuts and the key map of the active tool. In editors with a toolbar, tapping Alt or Option on macOS shows the hotkeys to change to a desired tool. Tip. This functionality can be disabled with the Alt-click tool prompt preference in the key map preferences. Status messages. The middle of the status bar displays information about in-progress operations. Running task. Shows the progress of the currently running task, such as rendering or baking. Hovering the mouse pointer over the progress bar will display a time estimate. The task can be aborted by clicking the Cancel button, X icon. Report message. Informational messages or warnings, such as after saving a file. They disappear after a short time. Click them to show the full message in the info editor. Resource information. The right side of the status bar displays information about the Blender instance. Which information is shown can be chosen by clicking RMB. Scene statistics. Collection. Name of the active collection. Active object. Name of the active selected object. Geometry. Displays information about the current scene depending on the mode and object type. This can be the number of vertices, faces, triangles, or bones. Objects. Number of the selected objects and the total count. System memory. Estimate of Blender's RAM consumption. In a single instance, single machine scenario, this estimate provides a measurement against the hardware limit of the machine. Blender version. The version of Blender that is currently running. User interface areas. Areas. Area boundaries are indicated by rounded corners, yellow highlights. The Blender window is divided into a number of rectangles called areas. Areas reserve screen space for editors, such as the 3D viewport or the outliner. Each editor offers a specific piece of functionality. Areas are grouped into workspaces, which are geared towards particular tasks, modeling, animating, and so on. Note: while some keyboard shortcuts in Blender are global, such as Ctrl+S for saving, many depend on which editor the mouse cursor is hovering over. As an example, say you just selected two objects in the outliner and want to join them. If you press the shortcut for this, Ctrl+J, while the cursor is still in the outliner, nothing would happen as the shortcut isn't valid there. You first need to move your cursor to the 3D viewport. Resizing. You can resize areas by dragging their borders with LMB. Move your mouse cursor over the border between two areas so that the cursor changes to a double-headed arrow, and then click and drag. Splitting. Splitting an area will create a new area. Placing the mouse cursor in an area corner will change the cursor to a cross, plus, to indicate that pressing down LMB will activate splitting or joining. Dragging from an area corner inward will split the area. You define the split direction by dragging either horizontally or vertically. Joining. Properties is being joined to the outliner. Dragging from an area corner outward will join two areas. The area that will be closed shows a dark overlay. You can select which area will be closed by moving the mouse over it. Release the LMB to complete the join. If you press Escape or RMB before releasing the mouse, the operation will be cancelled. Tip. The cursor will also turn into a cross when hovering over either end of the border between two areas. When splitting or joining, it's best not to start dragging from this border, but from a corner inside one of the areas. Area options. RMB on the border opens the area options. Vertical/horizontal split. Shows an indicator line that lets you select the area and position where to split. Tab switches between vertical/horizontal. Join areas. Shows the join direction overlay. Swap areas. Swaps this area with the adjacent one. Swapping contents. You can swap the contents of two areas by pressing Ctrl+LMB on one of the corners of the initial area, dragging towards the target area, and releasing the mouse there. The two areas do not need to be side by side, though they must be inside the same window. Duplicate area into new window. Reference. Menu. View area duplicate area into new window. A new floating window containing an area can be created from view area duplicate area into new window. Not available in some editors. The new window is a fully functional window, which is part of the same instance of Blender. This can be useful, e.g. if you have multiple monitors. You can also create a new window from an existing area by pressing Shift+LMB on an area corner, then dragging outward slightly. Toggle maximize area. Reference. Menu. View area toggle maximize area. Shortcut. Control spacebar. Expands the area so it fills the whole window, while keeping the top bar and status bar visible. To return to normal size, use the keyboard shortcut again or click the back to previous button in the top bar. Toggle full screen area. Reference. Menu. View area toggle full screen area. Shortcut. Control-Alt spacebar. Expands the area so it fills the whole window, hiding the top bar, status bar, and even the secondary regions, toolbars, etc., of the area's own editor. To return to normal size, use the keyboard shortcut again or click the icon in the area's top right corner, only becomes visible when. User interface regions. Every editor in Blender is divided into regions. Regions can have smaller structuring elements like tabs and panels with buttons, controls, and widgets placed within them. The regions of the 3D viewport showing the sidebar and the Adjust Last Operation panel after adding a cube dot. Header, green, main region, yellow, toolbar, blue, sidebar, red, and Adjust Last Operation panel, pink. Main region. At least one region is always visible. It is called the main region and is the most prominent part of the editor. Each editor has a specific purpose, so the main region and the availability of additional regions are different between editors. See specific documentation about each editor in the Editors chapter. Header. A header is a small horizontal strip, which sits either at the top or bottom of an area. All editors have a header acting as a container for menus and commonly used tools. Menus and buttons will change with the editor type and the selected object and mode. The header of the 3D viewport. Context menu. RMB on a header reveals a context menu with a couple options. Show header. Toggles the visibility of the header. If a header is hidden, it can be made visible again by clicking or dragging the small arrow that appears at the top/bottom right of the editor. Show tool settings. Toggles the visibility of the tool settings. Show menus. Toggles whether the menus are collapsed or not. Flip to bottom/top. Toggles whether the header or tool settings appear on the top or bottom of the editor. Vertical/horizontal split. Shows an indicator line that lets you select the area and position where to split. Tab switches between vertical/horizontal. Maximize/full screen area. See toggle maximize area. Duplicate area into new window. See duplicate area into new window. Close area. Closes the area and replaces it with the expansion of a neighboring area. Toolbar. The toolbar, on the left side of the editor area, contains a set of interactive tools. T toggles the visibility of the toolbar. Tool settings. A horizontal strip at the top or bottom of the editor, similar to the header, containing settings for the currently selected tool. Just like the header, it can be hidden and moved through its context menu. Adjust last operation. Adjust last operation is a region that allows tweaking an operator after running it. For example, if you just added a cube, you can use this region to tweak its size. Sidebar. The sidebar, on the right side of the editor area, contains panels with settings of objects within the editor and the editor itself. N toggles the visibility of the sidebar. Footer. Some editors show a bar on top/bottom of the editor area that displays information about, for example, the active tool or operator. Arranging. Scrolling. A region can be scrolled vertically and/or horizontally by dragging it with the MMB. If the region has no zoom level, it can also be scrolled by using the wheel while the mouse hovers over it. Some regions, in particular animation timelines, have scroll bars with added control points to adjust the vertical or horizontal range of the region. These special scroll bars will have added widgets at the ends, as shown in the following image. Scroll bars with zoom widgets. This can be used to stretch or compress the range to show more or less detail within the available screen space. Simply drag one of the dots to either increase or decrease the displayed range. You can also quickly adjust both the horizontal and vertical range by dragging in the editor with Ctrl+MMB. Changing the size and hiding. Resizing regions works by dragging their border, the same way as areas. To hide a region, resize it down to nothing. A hidden region leaves a little arrow sign. LMB on this icon to make the region reappear. Hiding and showing the sidebar. Scaling. The scale of certain regions, such as the toolbar, can be changed by dragging inside them with Ctrl+MMB or using numpad plus and numpad minus while hovering the mouse cursor over them. Press home to reset the scale to the default. Asset shelf. Search. To search for assets, hover your mouse over the asset shelf, then press Ctrl+F and type a search query. This will filter the poses to match what you typed. Tabs. The usage of catalogs as tabs. Catalogs can be shown as individual tabs. Each tab will only show its content and the content of its children. That makes it easy to filter down to a certain set of assets. Display options. Display options available for the asset shelf. It is possible to change the size of items on the shelf by using the size property. By toggling on the Names checkbox, the asset names will be shown in the shelf. Alternatively, it is also possible to hover over an item to show its name. By default, the shelf only has a height for one item row. To allow for more rows, drag it on the upper edge to increase its size. User interface tabs and panels. Tabs. Top, horizontal tab header in the top bar. Bottom, vertical tab header shows tab icons in the properties. Tabs are used to control overlapping sections in the user interface. The content of only one tab is visible at a time. Tabs are listed in a tab header, which can be horizontal or vertical. Switching/cycling. Vertical tabs can be switched with control wheel from anywhere in the tab. You can also cycle through tabs with Control Tab and Shift Control Tab, or press down LMB and move the mouse over the tab header icons. This does not apply to workspace tabs. See workspace controls. Panels. Panels in properties. A panel is highlighted in yellow and a subpanel in red. The smallest organizational unit in the user interface is a panel. The panel header shows the title of the panel. It is always visible. Some panels also include subpanels. Collapsing and expanding. A panel can either be expanded to show its contents or collapsed to hide its contents. An expanded panel is indicated by a down arrow in the panel header, while a collapsed panel is shown with a right arrow. Clicking LMB on the panel header expands or collapses it. Pressing A expands/collapses the panel under the mouse pointer. Clicking Ctrl LMB on the header of a collapsed panel will expand it and collapse all others. Clicking Ctrl LMB on the header of an expanded panel will expand/collapse all its subpanels. Dragging with LMB over the headers will expand or collapse many at once. Position. You can change the position of a panel within its region by clicking and dragging the grip widget, smiley face, colon on the right side of its header. Pinning. Sometimes it is desirable to view panels from different tabs at the same time. Like, for instance, having access to a camera's properties while other objects are selected. This has been solved by making panels pinnable. A pinned panel remains visible regardless of which tab has been selected. You can pin a panel by clicking on the pin icon in its header. Panels that do not have a pin icon can be pinned by RMB on the panel header and selecting Pin, or by pressing Shift LMB. Note: pinning is not available for all panels. For example, it's available in the sidebar but not in the Properties editor. Presets. Example presets menu. Selector. A list of available presets. A selection will override the included properties. Add plus. New presets can be added based on the currently applied set of properties, which will be saved for later reuse. A pop-up opens where you can set a name, after which you can select it from a list and in some cases additional settings. Removes. Deletes the selected preset. User interface common shortcuts. Conventions used in this manual. Keyboards. Hotkey letters are shown in this manual like they appear on a keyboard. For example, G refers to the lowercase g. Shift, Control, Alt are specified as modifier keys. Control W, Shift Alt A indicates that these keys should be pressed simultaneously. Numpad 0 to Numpad 9, Numpad Plus refer to the keys on the separate numeric keypad. Other keys are referred to by their names, such as Escape, Tab, F1 to F12. Of special note are the arrow keys, left, right, and so on. Mouse. This manual refers to mouse buttons as LMB, left mouse button, RMB, right mouse button, MMB, middle mouse button, wheel, wheel up and wheel down. Scrolling the wheel. Note: Blender has two main selection modes, left-click select and right-click select. See the select with mouse button preference. While left-click select is the default as it's the most common in other applications, right-click select does have its advantages. Learn the benefits of right-click select. Hovering. While hovering, when the cursor is held over a button. Properties. Control-C, copy the single value of the button. Control-V, paste the single value of the button. Control-Alt-C, copy the entire vector or color of the field. Control-Alt-V, paste the entire vector or color of the field. RMB, open the context menu. Backspace, clear the value, sets to 0 or clears a text field. Minus, negate number values, multiply by -1.0. Control wheel, change the value incremental steps. For pop-up option menus buttons, this cycles the value. Return, activates menus or toggles the value. Alt, hold while editing values to apply the change to all selected items, objects, bones, sequence strips. This can be used for number fields and toggles. Animation. I, insert a keyframe. Alt-I, clear the keyframe. Shift-Alt-I, clear all keyframes, removing all F-curves. Control-D, Assign a driver. Ctrl-Alt-D, clear the driver. T, add a keying set. Alt-K, clear the keying set. Python scripting. Ctrl-C over any operator buttons copies their Python command into the clipboard. This can be used in the Python console or in the text editor when writing scripts. Shift-Ctrl-C over property buttons copies their data path for this property, also available from the context menu. Useful when writing drivers or scripts. Shift-Ctrl-Alt-C over property buttons copies their full data paths for the data block and property. Note that in most cases it is best to access values based on the context, instead of by name. Dragging. Control, while dragging, snap to discrete steps. Shift gives precision control over the value. Shift Control, precise snap will move the object with high precision along with the snapping constraint. Text editing. Home, go to the start of the line. End, go to the end of the line. Left, right, move the cursor a single character. Control left, control right, move the cursor an entire word. Backspace, delete, delete characters. Control backspace, control delete, delete words. Shift, select while holding the key and moving the cursor. Control A, select all text. Control C, copy the selected text. Control X, cut the selected text. Control V, paste text at the cursor position. Confirm and cancel. Escape, RMB, cancel. Return, LMB, confirm. User interface default key map. While this isn't a comprehensive list, this page shows common keys used in Blender's default key map. Global keys. Ctrl-O. Open file. Ctrl-S. Save file. Ctrl-N. New file. Ctrl-Z. Undo. Shift-Ctrl-Z. Redo. Ctrl-Q. Quit. F1. Help, context sensitive. F2. Rename active item. S3. Menu search. F4. File context menu. S5, F8. Reserved for user actions. S9. Adjust last operation. F10. Reserved for user actions. F11. Show render window. F12. Render the current frame. Q. Quick access, favorites. Control spacebar. Toggle maximize area. Control page up / control page down. Next / previous workspace. Spacebar. User configurable. Play. Toggle animation playback. Tools. Tool switching with hotkeys, shift spacebar for play. Search. Search for actions, shift spacebar for play. Shift control spacebar. Playback animation, reverse. Common editing keys. X. Deletes the selected item, requires a confirmation dialog. Delete. Deletes the selected item, does not require a confirmation dialog. Common editor keys. These keys are shared across editors such as the 3D viewport, UV, and graph editor. A. Select all. Alt-A. Select none. Control-I. Invert selection. H. Hide selection. Alt-H. Reveal hidden items. T. Toggle toolbar. N. Toggle sidebar. 3D viewport keys. Tab. Toggle edit mode. Control tab. Toggle pose mode for armatures, or show a mode switching pie menu for others. 1 to 3. In edit mode, switch between editing vertices, 1, edges, 2, or faces, 3. Hold shift to toggle one of these without disabling the others. Hold Ctrl to alter how the selection is transformed from the old mode to the new. See Mesh Selection Modes for details. Accent Grave. Show 3D Viewport Navigation Pie menu. Control Accent Grave. Toggle Gizmos. Shift Accent Grave. Start Walk/Fly Navigation. Platform-specific keys. macOS. The CMD key can be used instead of Control on macOS for all but a few exceptions which conflict with the operating system. List of additional macOS-specific keys. CMD, Preferences. Keymap Preferences. Select with mouse button. Controls which mouse button, either left or right, is used to select items in Blender. If left is selected, the RMB will be a context-sensitive menu. If right is selected, the LMB will place the 3D cursor. Spacebar action. Controls the action of spacebar. These and other shortcuts can be modified in the Keymap Preferences. Play. Starts playing through the timeline. This option is good for animation or video editing work. Tools. Opens the toolbar underneath the cursor to quickly change the active tool. This option is good if you are doing a lot of modeling or rigging work. Search. Opens up the menu Search. This option is good for someone who is new to Blender and is unfamiliar with the menus and shortcuts. Activate Gizmo Event. The activation event for gizmos that support drag motion. This option is only available when left-click Select with mouse button is chosen. Press. The gizmo's operation gets initiated, and additional options become available in the status bar the moment you press down the mouse button on the gizmo. Drag. The operation only gets initiated once you start dragging the gizmo. Tool keys. The method of keys to activate tools such as Move, Rotate, and Scale. Immediate. Activate actions immediately. Active tool. Activate the tool for editors that support tools. Alt-click tool prompt. Tapping Alt shows a prompt in the status bar prompting a second keystroke to activate the tool. Note that this option is not available when using Emulate 3-button mouse. Alt tool access. Hold Alt to use the active tool when the gizmo would normally be required. For example, with the Move tool selected, you can hold Alt and drag the mouse anywhere in the viewport to move the selected object, rather than having to drag its gizmo. This option is only available when Select with mouse button is set to left-click and Emulate 3-button mouse is disabled. Select all toggles. Causes selection shortcut A to deselect all when any selection exists. Region toggle pie. N opens a pie menu to toggle regions, rather than toggling a single region. 3D viewport. Grave accent / action. Navigate. Navigation pie menu, useful on systems without a numeric keypad. Gizmos. Transform gizmos pie menu, useful for quickly switching between transform gizmos. Note that this doesn't apply to tools that force a certain gizmo, move, rotate, scale and transform. If you have such a tool selected, the gizmo will stay the same no matter what you choose in the pie menu. Middle mouse action. The action when MMB dragging in the viewport. This also applies to trackpads. Orbit. Rotates the view around a pivot point. Shift MMB is used for panning the view. Pan. Shifts the view towards the mouse. Shift MMB is used for orbiting the view. Alt middle mouse drag action. Relative. Set the view axis where each mouse direction maps to an axis relative to the current orientation. Absolute. Set the view axis where each mouse direction always maps to the same axis. Tab for pie menu. Causes tab to open a pie menu, swaps tab and control tab. Pie menu on drag. This allows keys to have a secondary drag action. Tab. Tab. Toggles edit mode. Drag. Object mode pie menu. Z. Tab. Tap. Toggles wireframe view. Drag. Display mode pie menu. Accent grave. Tap. First person fly/walk navigation. Drag. View axis pie menu. Extra shading pie menu items. Show additional items in the shading menu, Z key. Transform navigation with Alt. During transformations, use Alt to navigate the 3D viewport. When disabled, hotkeys for proportional editing, automatic constraints, and auto IK chain lengths will require holding Alt. File browser. Open folders on single click. Navigate into folders by clicking on them once instead of twice. User interface industry compatible key map. While this is not a comprehensive list, this page shows common keys used in the industry compatible key map. General. 1 to 3. Switch selection mode. Seer. Object mode. Size. Modes pie menu. RMB. Context menu. Tab. Menu search. Shift tab. Quick access, favorites. Return. Rename. Control return. Render. Control dash. Toggle toolbar. Control dash. Toggle sidebar. Common editing keys. Backspace. Deletes the selected item, requires a confirmation dialog. Delete. Deletes the selected item, does not require a confirmation dialog. Control D. Duplicate. P. Set parent. B. Proportional editing/soft selection. Viewport. Alt LMB. Orbit view. Alt MMB. Pan view. Alt RMB. Zoom view. S1, S4. Front/side/top/camera viewpoints. S. Frame selected. Shift F. Center view to mouse. A. Frame all. Selection. LMB. Select. Control A. Select all. Shift Control A. Deselect all. Control I. Select inverse. Up. Select more. Down. Select less. Double LND. Select loop. Double Alt LND. Select ring. Control L. Select linked. Tools. W, E, R. Transform tools. Q. Select tools. B. Annotate. C. Cursor tool. Edit mode tools. Control E. Extrude. Control B. Bevel. I. Inset. K. Nice. Alt C. Loop cut. Animation. Spacebar. Play/pause. S. Set location plus rotation plus scale keyframe. Shift S. Insert keyframe menu. Shift W. Set location key. Shift E. Set rotation key. Shift R. Set scale key. Platform specific keys. macOS. The Command key can be used instead of Control on macOS for all but a few exceptions which conflict with the operating system. User interface buttons. Operator buttons. Operator button dot. Operator buttons execute an operator which in summary execute an action when clicked with LMB. Operator buttons may be an icon, text, or text with an icon. Checkboxes and toggle buttons. Checkboxes and toggle buttons. These controls are used to activate or deactivate options. Use LMB to change their state. A tick is shown on checkboxes when the option is activated. Active status on toggle buttons is indicated either by color on the icon background or a change in icon graphics. Dragging. To change many values at once on or off, you can press down LMB and drag over multiple buttons. This works for checkboxes, toggles, and to select a radio button value. Radio buttons. Radio buttons. Radio buttons are used to choose one option from a selection of options. The active button is indicated by a colored background. Cycling. Use control wheel while hovering the mouse over radio buttons to cycle between the options. Direction buttons. Direction buttons. Clicking with LMB in the sphere and dragging the mouse cursor lets the user change the direction by rotating the sphere. Shortcuts. LMB, drag, rotates the direction. Control, while dragging, snaps to vertical and diagonal directions. User interface fields. Text and search fields. A text and a search field. Text fields show a rounded rectangular border, and optionally an icon and/or text inside the border. Text fields store text strings and provide the means to edit text by standard text editing shortcuts. For text fields with an icon and pop-ups, see Data ID. Number fields. Number fields. Number fields store values and units. The first type of number field shows triangles pointing left, less than sign, and right, greater than sign, on the sides of the field when mouse pointer is over the field. Sliders, a second type of number field, have a colored bar in the background to display values over a range, e.g. percentage values. The value can be edited in several ways. Incremental steps. To change the value in unit steps, click LMB on the small triangles, not available for sliders. You can also use control wheel while hovering over the field to edit the value. Dragging. To change the value with the mouse, hold down LMB and drag to left or right. Hold Control to snap to the discrete steps while dragging or Shift for precision input. Keyboard input. Press LMB or return to enter value by typing it with keyboard. When entering values by keyboard, number fields work like text fields. Press return or LMB outside the field to apply the change. Press escape or RMB to cancel. Press tab to jump to the next field or shift tab to go to the previous field. Press minus while hovering over a number field to negate the value. Multi-value editing. Multi-value editing. You can edit multiple number fields at once by pressing down LMB on the first field and then dragging vertically over the fields you want to edit. Finally, you can either drag left or right to adjust value with the mouse, or release the LMB and type in a value. Value limits. Most numerical values are restricted by soft limit and hard limit value ranges. Changing values by dragging with the mouse is restricted to the soft limit value range. Input via keyboard will allow the use of wider value ranges, but never wider than the hard limit. Expressions. You can enter mathematical expressions into any number field. For example, enter 3 by 2 or 10/5 plus 4 instead of 6. Even constants like pi, 3.142, or functions like sqrt, 2, square root of 2, may be used. See also. These expressions are evaluated by Python. For all available math expressions, see Math Module Reference. Expressions as drivers. You may want your expression to be re-evaluated after it is entered. Blender supports this using drivers, a feature of the animation system. Expressions beginning with hashtag have a special use. Instead of evaluating the value and discarding the expression, a driver is added to the property with the expression entered. The expression hashtag frame is a quick way to map a value to the current frame, but more complex expressions like hashtag fmod, frame, 24/24 are also supported. This is simply a convenient shortcut to add drivers which can also be added via the RMB menu. Units. As well as expressions, you can specify numbers and units. If no unit is given, then a default unit is applied. The unit system can be changed in scene settings. You can use either the unit abbreviation or the full name after the value. Examples of valid usage of length units include 1 centimeter, 1 m 3 millimeters, 1 m 3 millimeters, 2 feet, 3 feet per 0.5 kilometers, 2.2 millimeters plus 5 foot/3 inch, 2 yards. Note: using units. Decimal separator is optional. You can mix units, e.g. metric and imperial, even though you can only show one at a time. Plurals of the names are recognized too, so meter and meters can both be used. Color fields. Color fields. With and without alpha dot. The color field stores a color value. Clicking on it with LMB opens the color picker. Color fields with an alpha channel are divided in halves. On the left, the color is shown without an alpha channel, and on the right, it's shown with an alpha channel over a checker pattern. Colors can be copied to other color fields by dragging and dropping. User interface menus. Blender uses a variety of different menus for accessing options and operators. Menus can be interacted with in the following ways. Mouse selection. LMB on the desired item. Numerical selection. You can use the number keys or numpad to input an item in the list to select. For example, numpad 1 will select the first item and so on. If a menu is too large to fit on the screen, a small scrolling triangle appears on the top or bottom. Scrolling is done by moving the mouse above or below this triangle. Shortcuts. Use wheel while hovering with the mouse. Arrow keys can be used to navigate. Each menu item has an underlined character which can be pressed to activate it. Number keys or numpad can also be used to activate menu items. 1 for the first menu item, 2 for the second, etc. For larger menus, Alt 1 activates the 11th and so on, up to Alt 0 for the 20th. Press Return to activate the selected menu item. Press Escape to close the menu without activating any menu item. This can also be done by moving the mouse cursor far away from the menu, or by LMB clicking anywhere outside of it. Pop-up menus. Image menu in the header of the image editor. Pop-up menus list operators which can be executed by selecting with LMB or using the generated shortcut indicated by the underlined character of the operator name. All menu entries show any relevant shortcut keys, which can be executed without opening the menu. All pop-up menus can be searched by pressing spacebar and typing the name of the operator in the menu. If a pop-up menu has Search as one of the items, the menu can be searched without having to press spacebar first. All pop-up menus of an editor can be searched using the menu search feature. Collapsing menus. Sometimes it's helpful to gain some extra horizontal space in the header by collapsing menus. This can be accessed from the header context menu. Click RMB on the header and select Collapse Menus. Right-click on any of the header menus. Access the menu from the collapsed icon. Select Menus. The 3D viewport mode select menu. A select menu, or selector for short, lets you choose between a set of options. It appears as an icon and/or text with a down arrow on the right side. To use it, click the button with LMB to show the available options, then click the desired option. Once selected, it'll appear inside the button. You can also use Control Wheel to cycle through the options without opening the menu. Popover menus. The transform orientations popover menu. Popover menus are similar to select menus, but can show more varied content such as a title, buttons, sliders, etc. Context menu. Context menus are pop-ups that can be opened with RMB. In most editors, it's also possible to use the menu key. The contents of the menu depend on the location of the mouse pointer. When invoked in an editor, the menu contains a list of operators sensitive to the editor's mode. When invoked over buttons and properties, common options include single. Apply the change to a single value of a set, e.g. only the x-coordinate of an object's location. L. Apply the change to all values in a set, e.g. all coordinates of an object's location. Reset to default values backspace. Replaces the current value by the default. Copy data path Shift Control C. Copies the Python property data path relative to the data block. Useful for Python scripting. Copy full data path Shift Control Alt C. Copies the full Python property data path including any needed context information. Copy as new driver. Creates a new driver using this property as input and copies it to the clipboard. Use paste driver to add the driver to a different property, or paste driver variables to extend an existing driver with a new input variable. Copy to selected. Copies the property value to the selected object's corresponding property. A use case is if the property's context is pinned. Assign shortcut. Lets you define a keyboard or mouse shortcut for an operation. To define the shortcut, you must first move the mouse cursor over the button that pops up. When press a key appears, you must press and/or click the desired shortcut. Press escape to cancel. See also common shortcuts. Change shortcut. Lets you redefine the shortcut. Remove shortcut. Unlinks the existing shortcut. Online Manual S1. Opens an online page of the Blender manual in a web browser. Online Python reference. Context-sensitive access to the Python API reference. Edit source. For UI development, creates a text data block with the source code associated with the control, in case the control is based on a Python script. In the text editor, it points at the code line where the element is defined. Edit translation. For UI development, points at the translation code line. Specials menu. The Specials pop-up menu is similar to a context menu, but is opened using a button consisting of a down arrow on a dark background Specials button. Pie menus. A pie menu is a menu whose items are spread radially around the mouse. The 3D viewport mode pie menu. Tip. The fastest way to operate a pie menu is to press down the keys that invoke the menu, move the mouse slightly towards a selection, and release the keys to activate the selection. Releasing the key without moving the mouse will keep the menu open so you can click the desired item. If you do move the mouse before releasing, the item closest to the mouse will be activated instantly. An open disk widget at the center of the pie menu shows the current direction of the pie menu. The selected item is also highlighted. A pie menu will only have a valid direction for item selection if the mouse is touching or extending beyond the disk widget at the center of the menu. Pie menu items support key accelerators, which are the letters underlined on each menu item. Number keys can also be used. If there are subpies available, it is indicated by a plus icon. See also pie menu settings. User interface eyedropper. The eyedropper, pipette icon, allows you to sample from anywhere in the Blender window. The eyedropper can be used to select different kinds of data. Color. This is the most common usage. The eyedropper is used to sample a pixel's color from anywhere within Blender. Note: the view transform of the color management affects the color. In order to get consistent results, it should be set to standard. If it's set to any other option, the eyedropper may return an inaccurate color. Color ramp. Dragging the cursor over the window to sample a line which is converted into a color ramp. Object/object data. This is used with object buttons, such as parent, constraints, or modifiers, to select an object from the 3D viewport or outliner, rather than having to select it from a drop-down. Camera depth. Number fields affecting distance can also use the eyedropper. This is used to set the camera's depth of field so the depth chosen is in focus. E will activate the eyedropper while hovering over a button. LMB dragging will mix the colors you drag over, which can help when sampling noisy imagery. Spacebar resets and starts mixing the colors again. User interface decorators. Decorators are small buttons that appear to the right of other buttons and show the state of the property. Decorators may appear next to number fields, menus, and checkboxes to indicate the property can be animated. Decorators indicating different property states. Clicking on the decorator icon will add a keyframe to that property. Clicking the rhombus icon again will remove the keyframe. A solid rhombus icon indicates there is a keyframe on the current frame, while a non-solid rhombus icon indicates that the property has a keyframe on another frame. Clicking the non-solid rhombus icon will create a keyframe on the current frame with the current property value. If a property is being driven by another, the decorator shows the driver icon. Decorators make it quick and easy to glance over properties and see their state. See also state colors. User interface data block menu lets you select a data block, such as a material, in order to link it to something else, such as an object. A data block menu with a search field. Type shows an icon indicating the data block type. Clicking the image or the down arrow opens the pop-up menu. Dragging the image lets you apply the data block to something else. For example, you can drag a material onto an object in the 3D viewport or onto a data ID field. List. A list of data blocks available in the current blend file, or a link to select an item from. The menu may show a preview besides the items and a search field to search the items in the list by name. Name. Displays and allows editing of the name of the selected data block. If a name is already in use by a different data block, Blender will append a number like 0.001. User count. Displays the number of users of the data, if there's more than one user. Clicking it will create a single user copy. As an example, if 3 separate objects reference the same material, the material's user count would be 3. Changing the material would affect all 3 objects. If you now selected an object and clicked the user count, the object would receive its very own copy of the material, which can be modified independently of the original that's still used by the other 2. Fake user, shield icon. If a data block has no real users, it'll normally be cleaned up, deleted, when saving the blend file. To prevent this, you can give it a fake user. That way, it's guaranteed to survive. Data blocks with a fake user have an F prefix in the drop-down list. The outliner can show an overview of all data blocks without real users in the blend file. Simply change its display mode to orphan data. New/add files icon. Creates a new data block or duplicates the current one and selects it. Open file, folder icon. Opens the file browser for importing an image, for example. Unpack file, bin icon. Unpack the file packed into the current blend file to an external one. Unlink data block X. Clears the link. Shift-LMB to set the users to 0, allowing the data to be fully deleted from the blend file. Sometimes there is a list of applied data blocks, such as a list of materials used on the object. See also. Data blocks are discussed further in the Data System chapter. Preview. A data block menu with preview. Some data block menus have large preview images in their drop-down instead of just icons and names. Data ID. A data ID field. A data ID field is similar to a data block menu, but is only for selecting and not for other features like creating new data or managing users. It can show the following elements. Type. The icon on the left specifies the accepted data block type. Name. The text field functions as a search field by matching elements in the list. Press Tab to autocomplete names up to the level where a match is found. If more than one match exists, you have to continue typing. If you type an invalid name, the value will remain unchanged. List lets you select the data block directly. Eyedropper. In some data IDs there is an eyedropper available through the pipette icon on the right side. Removes X. Click the X button on the right to clear the reference. Sub-IDs. Related types of IDs may become available to select a property or child object, depending on the object type. Sub-ID example. Vertex group. If the selected object in the target field is a mesh or a lattice, an additional field is displayed where a vertex group can be selected. Bone. If the selected object in the target field is an armature, an additional field is displayed where a bone can be selected. Head/tail. Once a bone is selected, a numeric field becomes available for specifying a point on the bone. A value of 0 corresponds to the bone's head, while a value of 1 corresponds to its tail. Any values between these will result in linear interpolation, so a value of 0.5 matches the bone's center. Use debone shape. If the bone is a bendy bone, clicking on this button will make the point follow the curvature of the B-spline between head and tail, rather than simply going in a straight line. User Interface List View. List View with expanded filtering options panel. This control is useful for managing lists of items. In addition to the main list, there is a filtering panel on the bottom, hidden by default, and modification buttons on the right. Select. To select an item, click LMB on it. Rename. By double-clicking on an item, you can edit its name via a text field. This can also be achieved by clicking it with Ctrl-LMB. Resize. The list view can be resized to show more or fewer items. Hover the mouse over the handle, smiley face, then click and drag to expand or shrink the list. Filter. Click the Show Filtering Options button, triangle on bottom left, to show or hide the filter option panel. Search Ctrl+S. Filters the list to only show items containing a certain term. Invert dash. Toggle between including items that match the search term and those that do not contain the search term. Sort by name. This button switches between alphabetical and non-alphabetical ordering. Reverse. Sort objects in ascending or descending order. This also applies to alphabetical sorting, if selected. On the right of the list view are list modification buttons. Add plus. Adds a new item. Removes. Removes the selected item. Specials V. A specials menu with operators to edit list entries. Move, up/down arrow icon. Moves the selected item up/down one position. User Interface Color Picker. Circle HSV. The color picker is a pop-up that lets you define a color value. Holding Ctrl while dragging snaps the hue to make it quick to select primary colors. Color Field. Lets you pick the first and second color component. The shape can be changed, see Types. Color Slider. The slider with a gradient in the background lets you define the third color component. It can also be controlled with the wheel. Color Model. Selects the color model for the number fields below. RGB, HSV/HSL, hex. Note: in Blender, the RGB and HSV/HSL values are in seam linear color space and are therefore not gamma corrected. On the contrary, hex are automatically gamma corrected for the sRGB color space. For more information, see Color Management. Color Values. Blender uses values from 0 to 1 to express colors for RGB and HSV colors. Hexadecimal, hex, values are expressed as RRGGBB. Shorthand hex colors are also supported as RGB, e.g. dark yellow FFCC00 can be written as FC0. For operations that are capable of using the alpha channel, another slider K is added. Eyedropper, pipette icon, samples a color from inside the Blender window using the eyedropper. Shortcuts. Control LMB, drag, snaps to hue. Shift LMB, drag, precision motion. We'll adjust the brightness. Backspace reset the value. Types. The default color picker type can be selected in the Preferences, C, Interface. User Interface Color Ramp widget. Color ramps specify a color gradient based on color stops. Each stop has a position and a color. The gradient is then calculated as the interpolation between these stops using the chosen interpolation method. Color ramp dot. Controls. Add plus. Adds a new stop between the selected stop and the one before it. Delete. Deletes the selected color stop. Specials V. Contains more operators for the color ramp. Flip color ramp. Flips the gradient, mirroring the positions of the stops. Distribute stops from left. Distribute the stops so that every step has the same space to the right. This is mostly useful when used with constant interpolation mode. Distribute stops evenly. Distribute the stops so that all neighbors have the same space between them. Eyedropper, pipette icon, E. An eyedropper to sample a color or gradient from the interface to be used in the color ramp. Reset color ramp. Resets the color ramp to its default state. Color mode. Selection of the color model used for interpolation. RGB. Blends color by mixing each color channel and combining. HSV/HSL. Blends colors by first converting to HSV or HSL, mixing, then combining again. This has the advantage of maintaining saturation between different hues, where RGB would desaturate. This allows for a richer gradient. Color interpolation. The interpolation method to use across the ramp. RGB. B-spline. Uses a B-spline interpolation for the color stops. Cardinal. Uses a cardinal interpolation for the color stops. Linear. Uses a linear interpolation for the color stops. Ease. Uses an ease interpolation for the color stops. Constant. Uses a constant interpolation for the color stops. HSV/HSL. Clockwise. Clockwise interpolation around the HSV/HSL wheel. Counterclockwise. Counterclockwise around the HSV/HSL wheel. Near. Nearest route around the wheel. Far. Furthest route around the wheel. HSV and HSL interpolation options. Active color stop. Index of the active color stop, shown as a dashed line. Offers an alternative way of selecting a stop in case it's so close to others that it's hard to select it directly. Position. This slider controls the position of the selected color stop in the range. Color. A color field where you can specify the color and alpha of the selected stop. Shortcuts. LMB, drag, moves color stops. Control LMB, click, adds a new color stop. User interface color palette. Color palettes are a way of storing a brush's color so that it can be used at a later time. This is useful when working with several colors at once. Palette. A data block menu to select a palette. New plus. Adds the current brush's primary color to the palette. Delete. Removes the currently selected color from the palette. Move, up/down arrow icon. Moves the selected color up/down one position. Sort. Sort colors by hue, saturation, value, luminance. Color list. Each color that belongs to the palette is presented in a list. Clicking on a color will change the brush's primary color to that color. Shortcuts. Control LMB, open the color picker to change color. See color picker. Backspace, reset the value. User interface curve widget. The curve widget allows to intuitively map a range of input values to a set of output values by adjusting a curve, where the x-axis represents the input and the y-axis the output. Control points. Like all curves in Blender, the curve of the curve widget is controlled using control points. By default, there are two control points, one at 0.0, 0.0, and one at 1.0, 1.0, meaning the input is mapped directly to the output, unchanged. Move. Simply click and drag it around. Add. Click anywhere on the curve where there is not already a control point. Remove. Select it and click the X button at the bottom right. Controls. Above the curve graph is a row of controls. These are: zoom in plus magnifying glass icon. Zoom into the center of the graph to show more details and provide more accurate control. To navigate around the curve while zoomed in, click and drag in an empty part of the grass. Zoom out, minus magnifying glass icon. Zoom out of the graph to show fewer details and view the graph as a whole. You cannot zoom out further than the clipping region. See clipping below. Specials V. A specials menu with operators to edit control points or to set properties. Reset view. Resets the view of the curve. Extend options. Controls how the curve is extended before the first control point and after the last control point. Extend horizontal. Causes the curve to stay horizontal before the first point and after the last point. Extend extrapolated. Causes the curve to extrapolate before the first point and after the last point, based on the shape of the curve. Extend horizontal dot. Extend extrapolated dot. Reset curve. Resets the curve to default, removes all points added to the curve. Clipping options, die icon. Use clipping. Forces curve points to stay between specified values. Min x/y and max x/y. Set the minimum and maximum bounds of the curve points. Below the curve are options for the selected control point. Handle type. Controls how the control points affect the curve shape. It determines the interpolation of the curve segment at the selected control point. Vector handle. Vector handles create straight lines and sharp corners. Auto handle. Automatic handles that create smooth curves. Auto clamped handle. Automatic handles that create smooth curves while also preventing overshoot. Free handle. The handles can be moved completely independently and thus can result in a sharp change of direction. Aligned free handles. The two handles of the curve point are locked together to always point in exactly opposite directions. This results in a curve that is always smooth at the control point. X, Y. The coordinates of the selected control point. Delete X. Remove the selected control point. The first and last points cannot be deleted. Copy/paste Ctrl+C, Ctrl+V. The whole curve can be copied from one curve widget to another by hovering over the curve graph and pressing Ctrl+C, Ctrl+V. User interface search. Menu search. Reference. Mode. All modes. Menu. Edit menu search. Shortcut. S3. The menu search pop-up lets you search Blender's interface for a certain operator and execute it. First, narrow down the list by typing part of the operator's name, then either click the operator with LMB or navigate to it with down and up and activate it with return. Apart from the operator names, the pop-up also shows the menus where they're located. The menu search pop-up dot. See also the spacebar action option in the preferences. Operator search. Reference. Mode. All modes. Menu. Edit operator search. When developer extras are activated, the operator search can be accessed from the edit menu in the top bar. This menu searches all operators within Blender, even if they are not exposed in a menu. This is useful for Python developers for testing purposes. Blender might also include a few advanced operators that are not exposed in a menu and can only be accessed via this search menu. See also. The user preferences has an option to change how the search results are scored. User interface nodes introduction. Blender contains different node-based editors with different purposes, so this section only explains how to work with nodes in general. The list below shows the different types of nodes and where they're documented. Example of a node editor. Icon. Name. Documentation. Shader nodes. Documentation is in the render section. Composite nodes. Documentation can be found in the compositing section. Texture nodes. Texture nodes are covered in the UV editor docs. Editor interface. Header. The header contains various menus, buttons, and options, partially based on the current node tree type. Common node editor header options. View. This menu changes your view of the editor. Select. This menu allows you to select a node or groups of nodes. Add. This menu allows you to add nodes. Node. This menu allows you to do things with selected nodes. Use nodes. Tells the render engine to use the node tree when computing the material color or rendering the final image or not. If not, the tree is ignored. For materials, this is mostly a legacy option, because in the past materials could not be created with node trees. Use pinned. When enabled, the editor will retain the material or texture, even when the user selects a different object. A node tree can then be edited independent of the object selection in the 3D viewport. Parent node tree. Leaves the current node group and returns to the parent node group/tree. Snapping. Change options for snapping node positions to achieve a cleaner node tree layout. Overlays. Overlays are information that is displayed on top of the nodes and node trees. There is a toggle to show or hide all overlays for the node editor next to the overlay popover. Wire colors. Color node links based on their connected sockets. Context path. Display breadcrumbs in the upper left corner indicating the hierarchy location of the node tree/group that's currently being displayed. Annotations. Displays annotations in the preview region. Previews. Display each node's preview if the node's preview is also toggled. Toolbar. The toolbar contains a set of tools that can be used in the node editor. Sidebar. The sidebar region contains properties for the currently selected node as well as node editor-specific settings. Navigating. Navigating the node editors is done with the use of both mouse movement and keyboard shortcuts. Pan MMD. Move the view up, down, left and right. Zoom Control MMB, wheel. Move the camera forwards and backwards. Frame selected numpad period. Adjusts the zooms to fit only the selected nodes in the view. Frame all home. Adjusts the zoom to fit all nodes in the view. Adding nodes. Reference. Menu. Add. Shortcut. Shift-A. Nodes are added via the Add menu in the editor's header or using a keyboard shortcut. Nodes can also be added by dragging a connection from an existing node's input or output socket and dropping the connection above an empty space instead of connecting to another socket. This action will open a search menu with a list of compatible nodes and their sockets that can be added and connected to the existing node. Confirming the menu selection will add the node, which can then be moved and placed. User interface nodes. Node parts. All nodes in Blender are based on a similar construction. This applies to any type of node. These parts include the title, sockets, properties, and more. Title. The title shows the name/type of the node. It can be overridden by changing the node's label. On the left side of the title is the collapse toggle, which can be used to collapse the node. This can also be done with H. How a node appears when collapsed. Preview. Previews are an overlay that shows a small image above the node displaying the node result. Not all nodes support previews, but the ones that do can be toggled using the icon in the top right-hand corner of the node next to the title. Previews can be disabled for the whole node tree by using Previews Overlay Toggle. Preview Toggle Button. Sockets. Sockets are input and output values for the node. They appear as little colored circles on either side of the node. Unused sockets can be hidden with Ctrl-H. Each socket is color-coded depending on what type of data it handles. Built-in. Shader, bright green. Used for shaders in Cycles and EEVE. Geometry, turquoise. Used in geometry nodes. Data. Boolean, pink. Used to pass a true or false value. Color, yellow. Indicates that the socket accepts/produces color information. The colors may or may not have an alpha component depending on the node tree type. Float, gray. Indicates that the socket accepts/produces floating point numbers. It can either be a single value or a so-called value map. You can think of a value map as a grayscale image where the brightness of a pixel represents its value. If a single value is used as an input for a value map socket, all points of the map are set to this same value. Integer, lime green. Used to pass an integer value, a number without a fractional component. String, light blue. Used to pass a text value. Vector, dark blue. Indicates vector, coordinate, and normal information. Data blocks. Collection, white. Used to pass a collection data block. Object, orange. Used to pass an object data block. Material, salmon. Used to pass a material data block. Texture, pink. Used to pass a texture data block. Image, apricot. Used to pass an image data block. Inputs. The inputs are located on the bottom left side of the node and provide the data the node needs to perform its function. Each input socket, except for the green shader input, when disconnected, has a default value which can be edited via color, numeric, or vector interface input. In the screenshot of the node above, the second color option is set by a color interface input. Some nodes have special sockets that can accept multiple inputs. These sockets will have an ellipsis shape rather than a circle to indicate their special behavior. Outputs. The outputs are located on the top right side of the node and can be connected to the input of nodes further down the node tree. Conversion. Some socket types can be converted to others either implicitly or explicitly. Implicit conversion happens automatically without the need of a conversion node. For example, float sockets and color sockets can be linked to each other. Once a socket conversion is made, data may be lost and cannot be retrieved later down the node tree. Implicit socket conversion can sometimes change the data units as well. When plugging a value input node into an angle socket, it'll default to use radians regardless of the scene's units. This happens because the value node has no unit while the angle input does. Valid conversions. Between color and vector, mapping between color channels and vector components. Between color and float, the color data is converted to its grayscale equivalent. Color/float/vector to shader implicitly converts to color and gives the result of using an emission node. Explicit conversion requires the use of a conversion node such as the shader to RGB node or the RGB to BW node. The mass node also contains some functions to convert between degrees and radians. Properties. Many nodes have settings which can affect the way they interact with inputs and outputs. Node settings are located below the outputs and above any inputs. User interface node selecting. Box select. Drag with LMB to box select multiple nodes. Alternatively, B starts the bounding box selection process as well. Lasso select. Drag with Ctrl-Alt-LNB to perform a lasso selection. Note that this is different from the Ctrl-RMB used in other editors. Select all A. Select all nodes. Deselect all Alt-A. Deselect all nodes. Invert Ctrl-I. Invert the selection. Select linked from L. Expand the selection to nodes which are linked to the inputs of the currently selected nodes. Select link to Shift L. Expand the selection to nodes which are linked to the outputs of the currently selected nodes. Select group Shift G. Selects nodes that have similar properties as the active node. Type. The node type, e.g. all math nodes. Color. The node color. Nodes can be given a custom color to visually organize them in the editor. This is not related to any color information they might consume or produce as part of their function. The color can be set in the sidebar. Prefix, suffix. Matches the name property from start/end of the text. Activate same type previous/next shift-/shift-. Finds the previous/next node of same type, activates it, and ensures it's visible. Find node Ctrl-F. Shows a search pop-up for finding a node by name. Select multiple Shift-LMB. Add, remove a node to, from the selection. User interface nodes arranging nodes. Snapping. The snapping options can be found on the rightmost side of the node editor's header. Snap. Toggle snapping on or off. Snap node element. What to snap the selected nodes to. Grid. Snap to the grid in the background. Node X. Snap to the X coordinate of another node's vertical border. Node Y. Snap to the Y coordinate of another node's horizontal border. Node X/Y. Combination of the above. Snap target. Which part of the selected nodes to snap. Closest. Snap closest point onto target. Center. Snap center of selected nodes onto target. Median. Snap median of selected nodes onto target. Active. Snap active node onto target. Auto offset. When you drop a node with at least one input and one output socket onto an existing connection between two nodes, auto offset will, depending on the direction setting, automatically move the left or right node away to make room for the new node. Auto offset is a feature that helps organizing node layouts interactively without interrupting the user workflow. Auto offset is enabled by default, but it can be disabled in the user preferences. You can toggle the offset direction while you are moving the node by pressing T. The offset margin can be changed using the auto offset margin setting in the editing section of the preferences. See also. Example video. Auto offset. A workflow enhancement for Blender's node editors. User interface nodes editing. Transform. Reference. Menu. Node move, rotate, resize. Shortcut. G, R, S. You can move the selected nodes by simply clicking and dragging any empty part on them. Alternatively, you can press G, move the mouse, and click LMB to confirm. Dragging a node on top of an existing link will intelligently insert the selected node into the link path. This generally works by using the first socket that matches the link type. The automatic node attachment feature can be toggled with Alt. When a node is automatically attached, the surrounding nodes will be shifted to the right or left depending on the T toggle. See Auto Offset for more information on this feature. In general, it is recommended to arrange your nodes within the view such that the data flows from left to right, top to bottom. The width of a node can be changed by dragging its left or right border. Rotating, R, and scaling, S, only apply when you have multiple nodes selected and only affect the node's positions. Connecting sockets. LMB, click on a socket and drag. You will see a line coming out of it. This is called a link. Keep dragging and connect the link to an input socket of another node, then release the LMB. While multiple links can root out of an output socket, typically a single link can be attached to an input socket, that is unless the input is a multi-socket input which looks like a pill-shaped socket. To swap multiple links of a similar type, press and hold Alt while moving a link. This feature also works when adding a new link into a pre-existing socket. To reposition the outgoing links of a node, rather than adding a new one, hold Ctrl while dragging from an output socket. This works for single as well as for multiple outgoing links. Nodes that have no connections can be inserted on a link by just move the node over the link and release when the link is highlighted. Make links F. Select multiple nodes with open sockets, then use the Make Links to create links between them. Use Make Links again if there are other nodes which can be connected. Make and replace links Shift F. Make and replace links work similarly to make links, but it will replace existing links if any exist. Disconnecting sockets. Interactively. Drag the link away from its input socket and let it go, keeping it unconnected. Mute links. Reference. Menu. Node mute links. Shortcut. Ctrl-Alt-RMB. Activate the menu item or hold the key combination, then draw a line across one or more links to mute/unmute them. A muted link acts as though it's no longer there. This also means the input fields for specifying fixed values become visible again. When muting links on the input side of a reroute node, the links on its output side will be muted too. Cut links. Reference. Menu. Node cut links. Shortcut. Ctrl-RMB. Activate the menu item or hold the key combination, then draw a line across one or more links to delete them. Note: the key combination is normally reserved for lasso select. In node editors, lasso selection is instead performed with Ctrl-Alt-LMB. Detach links Alt-LMB drag. Use detach links to cut all the links attached to the selected nodes and move the nodes to a new location. Copy/paste. Reference. Menu. Node copy, node paste. Shortcut. Ctrl-C, Ctrl-V. Not only the selected nodes but also the connections between them are copied to the clipboard. Note: the pasted node will be placed in the same position as when it was copied. Use the same cautions as when duplicating. Duplicate. Reference. Menu. Node duplicate. Shortcut. Shift-D. Select one or more nodes, activate the menu item or press the key combination, then move the mouse to a new location, click LMB, or press Return to place the duplicated nodes. Note: when you duplicate a node, the new node will be positioned exactly on top of the node that was duplicated. If you leave it there, and it is quite easy to do so, you cannot easily tell that there are two nodes there. When in doubt, select a node and move it slightly to see if something is hidden underneath. Duplicate linked. Reference. Menu. Node duplicate linked. Shortcut. Alt-D. Duplicate selected nodes, but not their node trees, in the case of group nodes, and move them. Delete. Delete X, delete. Deletes the selected nodes. Delete with reconnect Ctrl-X. Deletes the selected nodes, then creates new links connecting their former input nodes to their former output nodes. Mute. Reference. Menu. Node toggle node mute. Shortcut. M. Muting a node removes its contribution to the node tree and makes all links pass through it without change. Links will appear red as an indicator of passing through the muted node. Tip: individual node links can be muted with mute links. Shows/hide. Hide H collapses the node so only the node header is visible. This can also be toggled by clicking the triangle on the left of the node header. Toggle node preview Shift H. Shows/hides a preview region on the node that displays the frame after that node's operation has been applied. This can also be toggled by clicking the material ball icon in the node header. Note: this operator are only available in the compositor. Toggle hidden node sockets Control H. Collapses/expands any input or output sockets that have no other nodes connected to them. Toggle node options. Shows/hides all node properties. Collapse and hide unused sockets. Applies both the toggle hidden node sockets and hide operations. Layers. Read render layers Control R. Reads all the current scene's render layers from cache, as needed. This can be used to save RAM while rendering because the render layers do not have to be saved in RAM. And also for recovering some information from a failed render. For this to work, cache result must be enabled. Note: this operator are only available in the compositor. User interface node sidebar. Node. Reference. Panel. Sidebar node. Node tab with a compositing render layers node selected. Node. Name. A unique node identifier inside this node tree. Label. Nodes can be given a title by modifying the text field. Color. By default, the node's background color is defined by the user theme. This color can be overridden by selecting a custom color in this panel. Custom node colors can be used to provide a visual cue to help distinguish some nodes from others. The button to the right of the checkbox lets you save colors as presets for reusing later on, much like a palette. Color. Color of the node background. Node color specials. This menu contains operators for working with nodes with custom colors. Copy color. Copies the color of the active node and applies it to all selected nodes. Properties. The properties that are shown depend on the type of node selected, e.g. a mixed node has different properties than a masked node. Tool. Reference. Panel. Sidebar region tool. Active tool. The info in this panel changes with the selected tool. View. Reference. Panel. Sidebar region view. Annotations. You can select the Annotate tool in the toolbar to make annotations in the node editor. See Annotate tool for more info. User interface nodes node groups. Example of a node group. Grouping nodes can simplify a node tree by hiding away complexity and reusing repetitive parts. Conceptually, node groups allow you to treat a set of nodes as though it were just one node. They're similar to functions in programming. They can be reused, even in different node trees, and can be customized by changing their parameters. As an example, say you created a wood material that you would like to have in different colors. One way of doing this would be to duplicate the entire material for every color, but if you did that, you'd have to go over all those copies again if you later wanted to change the density of the grain lines. Instead, it would be better to move the nodes that define the wood look into a node group. Each material can then reuse this node group and just supply it with a color. If you then later want to change the grain line density, you only have to do it once inside the node group, rather than for every material. Node groups can be nested, that is, node groups can contain other node groups. Note: recursive node groups are prohibited for all the current node systems to prevent infinite recursion. A node group can never contain itself or another group that contains it. Interface. When a node group is created, new group input and group output nodes are generated to represent the data flow into and out of the group. Furthermore, connections to input sockets coming from unselected nodes will become attached to new sockets on the group input node. Similarly, outgoing connections to input sockets of unselected nodes will become attached to the new group output node. If you want to pass an additional parameter into the group, a socket must be added to the group input node. To do this, drag a connection from the hollow socket on the right side of the group input node to the desired input socket on the node requiring an input. The process is similar for the group output regarding data you want to be made available outside the group. Sidebar. Reference. Panel. Sidebar group inputs, sidebar group outputs. The interface panel for editing groups. The sidebar lets you add, remove, reorder, and edit the sockets of the group's input and output nodes. Name. The name of the socket to display in the node's interface. Tooltip. The message displayed when hovering over socket properties. Currently only supported for Geometry Node Editor. Default. The value to use when nothing is connected to the socket. Min, max. The minimum and maximum value for the UI button shown in the node interface. Note, this is not a minimum or maximum for the data that can pass through the node. If a socket passes a higher value than the maximum, it will still pass into the node unchanged. Hide value. Hide the socket value even when the socket is not connected. Geometry nodes. Hide in modifier. Don't show the input value in the geometry node's modifier interface. This allows the input to be used in the context of a node group but not as a modifier input. This option is only available for geometry nodes and only for input sockets. Single value. Only allows single value inputs rather than fields. Make group. Reference. Menu. Node make group. Shortcut. Ctrl-G. To create a node group, select the nodes you want to include, then press Ctrl-G or click Group Make Group. A node group will have a green title bar. All selected nodes will now be contained within the node group. Default naming for the node group is node group 001, etc. There is a name field in the node group you can click into to change the name of the group. Change the name of the node group to something meaningful. When appending node groups from one blend file to another, Blender does not make a distinction between material node groups or composite node groups. So it is recommended to use some naming convention that will allow you to distinguish between the two types. Tip. The Add menu of each node editor contains an Output category with node types such as Material Output. These node types should not be confused with the Group Output node found in node groups, and should not be used in node groups either, only in the top-level node tree. Insert into group. Reference. Menu. Node insert into group. Moves the selected nodes into the active group node. To use, select a set of nodes, ending with the destination group node, then, running the operation will move those nodes into that group. The moved nodes are collected into a group of their own to preserve their connection context, having their own group input and output nodes. The group's existing input and output nodes are updated with new sockets, if any, from the new nodes. The node group must be edited to contain a single group input and a single group output node. Edit group. Reference. Menu. Node edit group. Header. Go to parent node tree. Shortcut. Tab, Control Tab. With a node group selected, press Tab to move into it and see its content. Press Tab again, or Control Tab, to leave the group and go back to its parent, which could be the top-level node tree or another node group. You can refer to the breadcrumbs in the top left corner of the node editor to see where you are in the hierarchy. Example of an expanded node group. Ungroup. Reference. Menu. Node ungroup. Shortcut. Ctrl-Alt-G. Removes the group and places the individual nodes into your editor workspace. No internal connections are lost, and now you can link internal nodes to other nodes in your workspace. Separate P. Separate selected nodes from a node group. Copy. Copy to parent node tree, keep group intact. Move. Move to parent node tree, remove some group. Reusing node groups. Reference. Menu. Add group. Shortcut. Shift-A. Existing node groups can be placed again after they're initially defined, be it in the same node tree or a different one. It's also possible to import node groups from a different blend file using file link/append. User interface nodes frame node. The frame node is useful for organizing nodes by collecting related nodes together in a common area. Frames are useful when a node setup becomes large and confusing, yet the reusability of a node group is not required. Properties. Label size. Font size of the label. For example, for subordinate frames to have smaller titles. Shrink. Once a node is placed in the frame shrinks around it so as to remove wasted space. At this point, it is no longer possible to select the edge of the frame to resize it. Instead, resizing occurs automatically when nodes within the frame are rearranged. This behavior can be changed by disabling this option. Text. When you need to display more comprehensive text, frame nodes can display the contents of a text data block. This is read-only, so you will need to use the text editor to modify the contents. Editing. Join a new frame. Reference. Menu. Node join in new frame. Shortcut. Ctrl-J. Make a new frame including the selected nodes. Add to frame. Reference. Shortcut. Ctrl-P. Once a frame node is placed, nodes can be added by dropping them onto the frame or by selecting the nodes then the frame and using Ctrl-P. This can be thought of as parenting the selection to the frame. Remove some frame. Reference. Menu. Node remove some frame. Shortcut. Alt-P. To remove nodes from a frame, select and use Alt-P. This can be thought of as unparenting the selection from the frame. User interface nodes reroute node. A node used primarily for organization. Reroute looks and behaves much like a socket on other nodes in that it supports one input connection while allowing multiple output connections. To quickly add a reroute node into an existing connection, hold Shift and RMB while sweeping across the link to add a reroute node. Properties. Input. Input value used for unconnected sockets. User interface tool system. Tools are accessed from the toolbar. This is a general introduction to tools. Individual tools have their own documentation. There can only be one active tool per workspace and mode. This tool is remembered. If you're in edit mode and have the extrude tool selected, then switch to object mode, which has no extrude tool, and back to edit mode, the extrude tool will still be active. Most tools are controlled using just LMB, though some also have modifier keys, shown in the status bar while using the tool. This can all be customized in the key map preferences. Some tools define gizmos, shear and spin for example, to help control them. Toolbar. Reference. Shortcut. T. Expanded tool group. The toolbar contains buttons for the various tools. Buttons with a small triangle in their bottom right corner are tool groups which can be opened by holding LMB on them for a moment, or dragging LMB to open them instantly. Hovering your cursor over a tool for a short time will show its name, while hovering longer will show the full tooltip. Resizing the toolbar horizontally will display the icons with 2 columns. Expanding it further will display the icon and its text. Pop-up toolbar. Reference. Shortcut. Shift spacebar. Pressing Shift spacebar will pop up a small toolbar right at your cursor for faster access. The shortcuts for selecting the tools are displayed on the right. Alternatively, you can map this action to spacebar in the key map preferences. Then you'll be able to use spacebar like a modifier key, similar to holding Control or Shift. For example, you can press spacebar T for transform, spacebar D for annotate, spacebar M for measure, and so on. See spacebar action. Quick favorites. Reference. Shortcut. 2. The Quick Favorites menu gathers your favorite tools. Any tool or menu item can be added to this pop-up menu via its context menu. Changing tools. If you have Alt-click tool prompt enabled in the key map preferences, tapping Alt will display a tool prompt in the status bar. You can then press a key to select the corresponding tool, or tap Alt again to cancel the prompt. Fallback tool. The fallback tool is the one that's selected by default, so the one at the top of the toolbar. You can change it by either holding LMB on the toolbar button or pressing Alt-W to get a pie menu. Cycling tools. If you bind a key to a tool which is part of a group, you can enable the cycle option in the key map editor. Successive presses will then cycle through the tools in that group. This is enabled by default for the selection tools in the 3D viewport. For example, pressing W will cycle between select box, select circle, and so on. Properties. Tools can have their own settings, which are available from multiple places. The Tool Active Tool panel in the sidebar N. The Active Tool tab in the Properties editor. The Tool Settings region below the area header. User Interface Operators. Operators execute an action the moment they're activated, which makes them different from tools, which require some sort of input. Operators can be started from operator buttons, pop-up menus, or menu search. Examples of operators include adding a new object, deleting it, or setting its shading to smooth. Operator properties. Most operators have properties that can be adjusted to refine their result. First run the operator, which will use its default settings, then adjust the properties in the Adjust Last Operation region. Modal operators. Modal operators exist as a concept in between tools and regular operators. They require some sort of interactive input. The action of a modal operator can be confirmed using LMB or return. To cancel a modal operator, use RMB or escape. Slider operators. Slider operators are used to interactively adjust a percentage value in the editor's header. You can adjust the percentage by dragging the slider left or right. This can be made coarser, snapping in 10% increments, by holding Control, and more precise by holding Shift. For some sliders, you can toggle Overshoot with E, which lets you go beyond the 0 to 100% range. User Interface Undo and Redo. The tools listed below will let you roll back an accidental action, redo your last action, or let you choose to recover to a specific point by picking from a list of recent actions recorded by Blender. Undo. Reference. Mode. All modes. Menu. Edit Undo. Shortcut. Ctrl-Z. If you want to undo your last action, just press Ctrl-Z. See also Memory and Limits Preferences to change undo settings. Redo. Reference. Mode. All modes. Menu. Edit Redo. Shortcut. Shift-Ctrl-Z. To roll back the undo action, press Shift-Ctrl-Z. Adjust Last Operation. Reference. Mode. All modes. Menu. Edit Adjust Last Operation. Shortcut. S9. You can tweak the parameters of an operator after running it. In editors that support it, there is a head-up display panel in the bottom left based on the last performed operation. Alternatively, you can create a pop-up with F9 which does the same thing. For example, if your last operation was a rotation in object mode, Blender will show you the last value changed for the angle, see Fig. Rotation, object mode, 60 degrees. Left, where you can change your action back completely by typing numpad 0. There are other useful options based on the operator, and you can not only undo actions, but change them completely using the available options. If you are in edit mode, Blender will also change its contents based on your last action taken. In the second example, on the right, the last operation was a move in object mode, but a scale on a face in edit mode, and, as you can see, the contents of adjust last operation are different because of the mode, edit mode, see Fig. Scale, edit mode, resize face. Right. Adjust last operation dot. Rotation, object mode, 60 degrees, dot. Scale, edit mode, resize face, dot. Tip. Some operations produce particularly useful results by using adjust last operation. For example, adding a circle in the 3D viewport. If you reduce the vertices to 3, you get a perfect equilateral triangle. Tip. The adjust last operation region can be hidden by view adjust last operation. Undo history. Reference. Mode. All modes. Menu. Edit undo history. The undo history menu dot. There is also an undo history of the last actions taken, recorded by Blender. The top of the list corresponds to the most recent actions. A small icon of a dot next to one of the entries indicates the current status. Rolling back actions using the undo history feature will take you back to the action you choose. Much like how you can alternate between going backward in time with undo and then forward with redo, you can hop around on the undo timeline as much as you want as long as you do not make a new change. Once you do make a new change, the undo history is truncated at that point. Selecting one of the entries in the list takes the current status to that position. Repeat last. Reference. Mode. All modes. Panel. Edit repeat last. Shortcut. Shift-R. The repeat last feature will repeat your last action when you press Shift-R. In the example images below, we duplicated a monkey mesh and moved it a bit. Using repeat Shift-R, the monkey was duplicated and moved a second time. Suzanne dot. After a Shift-D and move dot. After a Shift-R dot. Repeat history. Reference. Mode. All modes. Menu. Edit repeat history. The repeat history menu dot. The repeat history feature will present you a list of the last repeated actions, and you can choose the actions you want to repeat. It works in the same way as the undo history, explained above, but the list contains only repeated actions. Important. When you quit Blender, the complete list of user actions will be lost, even if you save your file before quitting. See also Troubleshooting section on recovering your lost work. User interface annotations. The annotation tool is available in multiple editors. It can be used to add notes to e.g. 3D objects or node setups. The arrow in the screenshot below is an annotation. Annotations tool in a node editor dot. Annotation tools. The annotation tool can be activated in the toolbar and has the following subtools. Annotate. Draw freehand strokes in the main area. Annotate line. Click and drag to create a line. Optionally, you can select the arrow style for the start and end of the line. Annotate polygon. Click multiple times to create multiple connected lines, then press RMB, return or escape to confirm. Annotate eraser. Click and drag to remove lines. The eraser has a radius setting found in Tool Settings. Tool Settings. Common. Color. Adjust the color of existing and new strokes. Annotation layer. A popover menu showing the name of the current layer to access the annotation layers. Placement. Determines where the annotations are drawn. 3D cursor. Only available in the 3D viewport. The new annotations become part of the 3D scene. They're drawn on an imaginary plane that goes through the 3D cursor and is aligned to your view. Surface. Only available in the 3D viewport. The new annotations become part of the 3D scene. They're drawn onto the surface of the object under the mouse. If there is no surface, you get the same behavior as 3D cursor. Image. Only available in 2D editors such as the image editor. The annotations become part of the 2D space, meaning their position and size change as you pan and zoom in the editor. View. The new annotations are 2D and get stuck to the screen. They keep the same position, rotation, and size no matter how you pan, orbit, or zoom in the editor. Stabilize stroke. Helps to reduce jitter of the strokes while drawing by delaying and correcting the location of points. Radius. Minimum distance from the last point before the stroke continues. Factor. A smooth factor, where higher values result in smoother strokes, but the drawing sensation feels like as if you were pulling the stroke. Annotate line. Style start, end. The decoration to use at the beginning or end of the line segment. This can be used, for example, to create arrows to point out specific details in a scene. Annotation layers. When the annotation tool is enabled, the settings for managing multiple layers can be found in the sidebar view annotations panel. Opacity. Adjusts the opacity of existing and new strokes. Thickness. Adjusts the thickness of existing and new strokes. Onion skin. Shows a ghosted image of strokes made in frames before and after the current frame. Onion skinning only works in the 3D viewport and sequencer. See the grease pencil documentation for an explanation of onion skinning. Before/after. Color to use before and after the current frame on ghost frames. The number defines how many frames to show before and after the current frame. User interface selecting. By default, Blender uses LMB to select items. This can be changed to RMB in the preferences. Blender has several selection tools that can be used across the different editors. Note: some editors deviate from the keyboard shortcuts shown below. For example, most editors use Shift-LMB to add a single item to the selection, but the outliner uses Control-LMB. Similarly, most editors use Control-RMB for performing a lasso select, but node editors use Control-Alt-LMB. Most selection tools come in two variants, where one variant is available in the toolbar and the other in the select menu. While the variants' names are almost identical, such as select box in the toolbar versus box select in the menu, the way they work is a bit different. New users coming from other applications will find the toolbar variants to be the most familiar. Toolbar selection tools. All the toolbar selection tools behave the same when clicking an item. They select it and deselect any previously selected items. If you hold Shift while clicking, the item will be added to the selection if it's not selected, or removed from the selection if it is selected. What makes the tools different is what happens when you drag. Tweak. Reference. Tool. Toolbar tweak. Shortcut. W. Dragging an item will move it around. Select box. Reference. Tool. Toolbar select box. Shortcut. W. Dragging will create a rectangle and select all the items that are partially or completely inside it once you release. Any other items will be deselected. Holding Shift while dragging will add the items to the selection. Holding Control will remove them. While dragging, you can additionally hold spacebar to move the rectangle around with the mouse. Select circle. Reference. Tool. Toolbar select circle. Shortcut. W. Dragging will select all the items which the circle passed over. Items which you didn't pass over will be deselected. Holding Shift while dragging will add the items to the selection. Holding Control will remove them. You can change the radius of the circle in the tool settings, which can be found in the area header, the tool tab of the sidebar N, or the active tool tab of the properties editor. Note: in object mode, unlike Select Box, which selects objects as soon as the box covers any part of their geometry, Select Circle only selects objects if the circle passes over their origin point. The origin is shown as an orange dot for selected objects but is invisible for unselected ones, unless Origins, All, is enabled in the viewport overlays. This difference in behavior does not apply to the other modes, like Edit Mode and Pose Mode. Select Lasso. Reference. Tool. Toolbar select Lasso. Shortcut. W. Dragging will create a freeform shape and select all the items inside it once you release. Any other items will be deselected. Holding Shift while dragging will add the items to the selection. Holding Control will remove them. While dragging, you can additionally hold Spacebar to move the shape around with the mouse. Note: Select Lasso behaves the same as Select Circle in that it only looks at origin points in object mode. Selection modes. Reference. Tool. Select Tools. Panel. Tool Settings Mode. Each of the toolbar selection tools has a mode to configure how it interacts with existing selections. Note that not every tool supports all of these modes. Set. Sets a new selection, the previous selection is discarded. This is the default. Extend. Adds newly selected items to the existing selection. Subtract. Removes newly selected items from the existing selection. Invert Control-I. Inverts the selection, unselected items become selected and vice versa. Intersect. Selects items that intersect with the existing selection. Menu Selection Tools. These tools are variants of the previously described ones. They're available in the menu rather than the toolbar and work slightly differently. Box Select. Reference. Menu. Select Box Select. Shortcut. B. To use this tool, you first activate the menu item or keyboard shortcut and then drag a box as usual. Unlike Select Box, the default behavior here is to add the items inside the box to the selection. The ones outside the box are not deselected. To remove the items inside the box from the selection, hold Shift or drag with MMB instead. While dragging, you can additionally hold Spacebar to move the box around with the mouse. Circle Select. Reference. Menu. Select Circle Select. Shortcut. C. To use this tool, you first activate the menu item or keyboard shortcut and then drag a circle around as usual. Unlike Select Circle, the default behavior here is to add the items inside the circle to the selection. The ones outside the circle are not deselected. To remove the items inside the circle from the selection, hold Shift or drag with MMB instead. You can change the radius of the circle by scrolling with the wheel or using the numpad plus and numpad minus keys. Once activated, Circle Select stays active. You can release the mouse button and start dragging somewhere else without having to press C again. At the same time, however, it blocks all other parts of Blender while it's active. To deactivate the tool again, press RMB, Return, or Escape. Lasso Select. Reference. Menu. Select Lasso Select. Shortcut. Control RMB. To use this tool, you first activate the menu item and drag a freeform shape around the items you want to select with LMD. The menu lets you choose whether to set, extend, or reduce the selection. Alternatively, you can immediately start dragging with Control RMB. Unlike Select Lasso, the default behavior then is to add the items inside the lasso to the selection. The ones outside the lasso are not deselected. To remove the items inside the lasso from the selection, drag with Shift Control RMB instead. While dragging, you can additionally hold Spacebar to move the lasso around with the mouse. User Interface Node Sidebar. Node. Reference. Panel. Sidebar node. Node tab with the compositing render layers node selected. Node. Name. A unique node identifier inside this node tree. Label. Nodes can be given a title by modifying the text field. Color. By default, the node's background color is defined by the user theme. This color can be overridden by selecting a custom color in this panel. Custom node colors can be used to provide a visual cue to help distinguish some nodes from others. The button to the right of the checkbox lets you save colors as presets for reusing later on, much like a palette. Color. Color of the node background. Node color specials. This menu contains operators for working with nodes with custom colors. Copy color. Copies the color of the active node and applies it to all selected nodes. Properties. The properties that are shown depend on the type of node selected, e.g. a mixed node has different properties than a masked node. Tool. Reference. Panel. Sidebar region tool. Active tool. The info in this panel changes with the selected tool. View. Reference. Panel. Sidebar region view. Annotations. You can select the Annotate tool in the toolbar to make annotations in the node editor. See Annotate tool for more info. User interface node sidebar. Node. Reference. Panel. Sidebar node. Node tab with the compositing render layers node selected. Node. Name. A unique node identifier inside this node tree. Label. Nodes can be given a title by modifying the text field. Color. By default, the node's background color is defined by the user theme. This color can be overridden by selecting a custom color in this panel. Custom node colors can be used to provide a visual cue to help distinguish some nodes from others. The button to the right of the checkbox lets you save colors as presets for reusing later on, much like a palette. Color. Color of the node background. Node color specials. This menu contains operators for working with nodes with custom colors. Copy color. Copies the color of the active node and applies it to all selected nodes. Properties. The properties that are shown depend on the type of node selected, e.g. a mixed node has different properties than a masked node. Tool. Reference. Panel. Sidebar region tool. Active tool. The info in this panel changes with the selected tool. View. Reference. Panel. Sidebar region view. Annotations. You can select the Annotate tool in the toolbar to make annotations in the node editor. See Annotate tool for more info.